My screen is visible to all of you.
Yes, sir.
Okay, fine. Okay, so today we will start with this unit, that is architecture of commercial devices. That is unit number 6 of our syllabus of DDH. Okay. Up till now we have covered the first unit, that is the EDA tool and VHDL programming. That unit number second, VHDL modules for the different sequential as well as combinational logic designs. Then unit number 3, Verilog modules for the different combinational and sequential logic design. Then unit number 4, that is state machines. It is just the extension of that unit number second. Then we have studied about the different testing methods that are very essential to what we can say, check the functionality of any target board or any device or any digital design, right? So that we have discussed. So now today we are going to discuss the actual different hardwares that are available, right, for to implement these digital designs, or rather I will say a complex digital designs, right? So there are many CPLDs are available, there are different ASICs are available, FPGAs are available. So that all things we will cover in this unit. Okay. So architecture of commercial devices. This is the title of our unit number 6. Now we will start with the very basic terminology. That is, what do you mean by PLA? That is programmable logic devices. Okay. So this PLD, that means programmable logic devices, is an IC that contains large number of gates, then flip-flops, right? Or it can be configured or programmed by the user. That means PLD, that is programmable logic devices, right? So it's a kind of IC, and that IC contains a n number of gates, n number of flip-flops, and you can program that device or you can configure that device. Okay. So the PLDs are typically built with an array of AND gates and an array of OR gates. So this PLD consists of AND array as well as OR array, right? This combinedly forms the PLD, that is programmable logic device. It consists of AND array and also it consists of OR array. Okay. So this PLD, that means this programmable logic devices, it's the you can say a basic building block of the digital system design, right? So it's a IC, right? Whenever you are designing something, you have to form what we can say a robust design out of that. That means either you have to form ASIC, either you have to form some IC, either you have to form some boards with different peripherals and all that, right? So that is, that comes under the PLD part, that is programmable logic devices. And what include in this PLD? So it has n number of flip flops, n number of logic gates, right? And the what we can say significance of this PLD is you can configure or you can program this as a user. As a user, you can configure this or program this. Okay. Now this PLDs consist of AND array as well as OR array. That means AND array logic and OR array logic, right? So this is about the PLD. Then we have to study the different types of PLD, right? So we have studied about the PLD. Okay, that is the basic block. Okay, but what are different types of programmable logic devices are available with us? So first one is a PROM, that is programmable read-only memory. This is the first type. Second one is a programmable logic array, that is PLA. Third one is a PAL, that is programmable array logic. Okay. The next one is a complex programmable logic devices, that is CPLD. It's a PLD only, but with complexity increased. That means it has what we can say a more complex structure or more complex design than the normal PLD. And the last one is FPGA, right? What is long form of FPGA? So it is a filled programmable gate array. I will repeat. What is FPGA? Filled programmable gate array. Okay. So these are the main 5 types of the PLDs that are available with us. Okay. And now what do you mean by PLD? So PLD is a basically IC which consists of different flip-flops, gates and all the things. And its structure, if you talk about its structure, then it has combination of AND array logic as well as OR array logic. Okay, so this is about the PLD. Now, what are the types of PLD that we have? So these are the different types of PLDs that we have. We have a PROM, we have a PLA, that is programmable logic array. Then we have a PAL, programmable array logic. Then we have a CPLD, that is complex programmable logic devices. Then we have a FPGA, that is filled programmable gate array. So these are the types of PLDs that are available. Okay, so we will discuss the difference between all these types of PLDs. Okay, so what do you mean by PROM? Right. So this programmable read-only memory has fixed AND array and programmable OR array. बरोबर आहे. आपण बेसिक पीएलडीचं स्ट्रक्चर पाहिलं. बेसिक पीएलडीचं स्ट्रक्चर काय? It should have AND array logic and OR array logic. Okay. Now, the depending upon difference between that AND array logic and OR array logic, we can differentiate that PLDs into 5 types, such as PROM, PAL, PLA, CPLD, and FPGA. Right? Now, what is difference between the PROM, PAL, and PLA? That now we will discuss. Okay. Now, in case of PROM, that is programmable logic, programmable read only memory, and array त्यातला जो असतो तो फिक्स्ड असतो. राईट, इट हॅज अ फिक्स्ड अँड अरे, दॅट मीन्स इट विल ऍक्ट ॲज अ डिकोडर. आणि जो ऑर अरे असतो तो प्रोग्रामेबल असतो. बरोबर आहे. आपण बेसिक पीएलडीचं स्ट्रक्चर पाहिलं. पीएलडी म्हणजे काय? इट इज अ आयसी विच कन्सिस्ट ऑफ एन नंबर ऑफ फ्लिप फ्लॉप्स अँड गेट्स. ओके, बट व्हॉट इज द स्ट्रक्चर ऑफ मीन्स what is the basic structure of PLD, that is programmable logic devices? So it has AND array logic, it has OR array logic, right? That combination you can call it as a PLD. And within that AND array and OR array, you can have n number of flip flops, n number of gates, right? You can have different components. That is not issue. But basic structure is it must have AND array logic and OR array logic. ह्याला आपण PLD म्हणतो. मग त्या पीएलडीचे टाइप्स किती आहेत? प्रॉम, प्रोग्रामेबल रीड ओनली मेमरी, प्रोग्रामेबल अरे लॉजिक, प्रोग्रामेबल लॉजिक अरे, कॉम्प्लेक्स प्रोग्रामेबल लॉजिक डिव्हाइसेस, दॅट इज सीपीएलडी, आणि एफपीजीए, फील्ड प्रोग्रामेबल गेट अरे. हे त्याचे 5 टाइप. त्यातला पहिला टाइप कुठला? प्रॉम, प्रोग्रामेबल रीड ओनली मेमरी. व्हॉट इज डिफरन्स बिटवीन दिस, और व्हॉट इज स्पेशालिटी ऑफ दिस प्रॉम? सो इन केस ऑफ दिस प्रॉम, it has a fixed AND array and programmable OR array, right? So this PROM has fixed AND array and programmable OR array. So this is about the PROM. Now comes to the programmable array logic, that is PAL. Now what is significance of this PAL? So in case of this programmable array logic, it has programmable AND array and fixed OR array. समजतंय? प्रॉम मध्ये काय असतं? अँड अरे फिक्स असतो, ऑर अरे प्रोग्रामेबल असतो. पीएल, प्रोग्रामेबल अरे लॉजिक मध्ये काय असतं? अँड अरे प्रोग्रामेबल असतो, ऑर अरे फिक्स असतो. अँड द थर्ड वन इज प्रोग्रामेबल लॉजिक अरे. इन केस ऑफ पीएलए, द बोथ अरेज आर प्रोग्रामेबल. म्हणजे त्याच्यात अँड अरे पण प्रोग्रामेबल असतो आणि ऑर अरे पण प्रोग्रामेबल असतो. सो दीज आर द what we can say difference between this PROM, PAL and PLA. समजलंय सगळ्यांना? Okay. Now next part is again in this programmable logic devices, right? What are the programming, how actually this programmable, म्हणजे आपण जे म्हणतोय की programmable logic devices. So how this actually programming is done, or what do you mean by this programming? So this diagram will illustrate that. So first device is a before programming. That diagram A is before programming, that all switches are connected. Then after programming, what will happen? depending upon your design, you can remove certain switches or you can close certain switches, right, which are already closed. So you can remove that fuse connections. That means you can remove that connection and you can form the programmable connection. That means whatever you want, you will have that only. So in case of first, you have ABCD input. At the output, you are getting the ABCD. Why? Because all inputs are connected. But after programming, now you can get only two connections from B and C. That means now at the output of after programming that PLD, you will get only BC as output. That means only two inputs. Why? Because we have now programmed that. We have now programmed that array. So this is about the programmable logic devices. Okay. Now next part is structure of this PROM. So how this structure of this PROM look like? So this is what the structure of this PROM. PROM मध्ये काय असतं, जे डिकोडर आहे, डिकोडर that is the AND array. It has fixed. Decoder म्हणजेच इथं AND array आहे. AND array is a fixed, and that memory or that what you can say, that memory 2 into n word, right? It is actually OR array, and that is programmable. That OR array is programmable, but that decoder, that means that AND array, is fixed one. Okay, so this is a structure of the PROM. It has decoder with inputs, n number of input line. Decoder is nothing but AND array, which is fixed one, and the input of that AND array is given to the OR array, that is a kind of memory, and that is programmable. That memory is programmable, right? So this is the structure of a PROM. Okay, now we will talk about the PLA, that is programmable logic array. Now what is a speciality of this PLA? In case of this PLA, both is programmable. म्हणजे AND array पण programmable आहे आणि OR array पण programmable आहे. So this is how the structure of PLA look like. बरोबर आहे? तुम्हाला बेसिक फरक समजलाय का PROM मध्ये, PAL मध्ये आणि PLA मध्ये? PROM मध्ये काय? फिक्स्ड AND array लॉजिक, प्रोग्रामेबल OR array लॉजिक. PAL that is programmable array logic, त्याच्यात काय असतं? प्रोग्रामेबल AND array, फिक्स्ड OR array. आणि PLA programmable array, programmable logic array. In that case, both are programmable. That means AND array as well as OR array, both are programmable. PLA structure means what? In this AND array as well as OR array, both are programmable, right? So this is the typical structure for this programmable logic array. Now this is the structure for PAL. बरोबर आहे? PAL मध्ये काय असतं? It has programmable AND array but fixed OR array. बरोबर आहे का नाही? PL मध्ये काय असतं? OR array fixed असतो आणि AND array programmable असतो. That is written there only. So you can see first structure is that AND array which is programmable. That means you can actually connect or select different connections, but OR array is fixed one. OR array is fixed one, right? So in case of this PLA, easier to program but not as flexible as a PLA. So this PAL is easier to program, right, but not flexible as a PLA. Why? Because PLA has both array programmable, पण PAL मध्ये फक्त AND array programmable आहे. OR array is fixed. It's a fixed one. Okay, so this is about the typical structure of PAL, that is programmable array logic. Okay, now this is the difference between PLA, PAL and SPLD. Okay, that is the simple programmable logic devices. So this PLA, that means programmable logic array, is a relatively small FPD that contains two levels of logic, and AND plane as well as OR plane, and both levels are programmable. बरोबर आहे? हे शिकलो का नाही आपण PLA मध्ये? म्हणजे AND array पण प्रोग्रामेबल आहे आणि OR array पण प्रोग्रामेबल आहे. PAL मध्ये काय असतं? It is a relatively small FPD which has programmable AND plane, that means AND array, followed by fixed OR plane, that means followed by fixed OR array. So this is about the PAL. And in case of simple PLD, so this simple PLD can be either a PLA or PAL. म्हणजे PLA किंवा PAL लाच तुम्ही काय म्हणू शकता, SPLD, दॅट इज सिम्पल प्रोग्रामेबल लॉजिक डिव्हाइसेस. बरोबर आहे. PLA किंवा PAL म्हणजेच काय, SPLD, that is simple programmable logic devices, right? So this is about the PLA and PAL. Okay, now now what happens if both structures are programmable? बरोबर आहे. म्हणजे बघा, आपण चारही स्ट्रक्चर शिकलो, अँड अरे आणि ऑर अरे. बरोबर आहे. रॉम मध्ये काय असतं, अँड अरे पण फिक्स्ड असतो आणि ऑर अरे पण फिक्स्ड असतो, ते झाला रॉम. प्रॉम मध्ये काय असतं, अँड अरे फिक्स असतो, ऑर अरे प्रोग्रामेबल असतो, ते झाला प्रॉम, दॅट इज प्रोग्रामेबल. PAL प्रोग्रामेबल अरे लॉजिक मध्ये काय असतं, अँड अरे प्रोग्रामेबल असतो, ऑर अरे फिक्स असतो. आणि जेव्हा दोन्ही प्रोग्रामेबल असतात, that is nothing but PLA, programmable logic array. In that case, AND array as well as OR array both are programmable. And when both are fixed one, that means fixed AND array as well as fixed OR array, then that is ROM, read only memory. That is not PROM. In PROM, OR array has to be programmable. PROM मध्ये काय असतं, OR array programmable असतो. पण in a simple ROM, that is read only memory, it has fixed AND array as well as fixed OR array. Clear? So this is about the ROM, read only memory. Okay, now this tree diagram will actually show you a different types of integrated circuit, that is IC, that are available, and how actually these integrated circuits are categorized. Okay, so the integrated circuit first have three main types. First is a full custom ASIC, then semi-custom ASIC, and last one is a user programmable devices. Now in that user programmable devices, again you have PLD and FPGA, right? In that you have a PLD and FPGA. In that programmable logic devices, you can have PAL, then PLA, then PROM, then SPLD. Okay, I have not mentioned there, but PROM is also kind of PLD. Then ROM is there, then SPLD is there. So these are the different types of PLDs. Now in case of FPGA, again you have different lookup tables, mux and gates, right? So this is the what we can say category of the integrated circuit, or in this way the integrated circuit you can differentiate or you can categorize. Okay, so integrated circuit has three different categories: full custom ASIC, semi-custom ASIC, and user programmable. Now in that user programmable, again you have two categories, PLD and FPGA. And again that PLD you have PAL, PLA, and EML. And that FPGA is consist of different lookup table, mux, and gates. So this is the generalized what we can say category or generalized tree diagram for the integrated circuits. Okay, now next thing is ASIC. Okay, now we will discuss about the ASIC. What do you mean by ASIC? So ASIC is a application specific integrated circuit. Okay, ASIC is what? Application specific integrated circuit, and it is an integrated circuit customized for a particular use rather than intended for a general purpose use, right? We have cleared this thing. Okay, so even I have given one example for you also. What is the best example of ASIC? Is your cell phone chip or your smartphone chip. That is the best example of ASIC. Okay, that chip is designed for only the mobile applications. बरोबर आहे. आपल्या स्मार्टफोन मधली जी चिप असते ती सुद्धा एक प्रकारचा ASIC आहे, किंवा दॅट इज ऍक्च्युअली द बेस्ट एक्झाम्पल ऑफ ASIC, दॅट इज ऍप्लिकेशन स्पेसिफिक इंटिग्रेटेड सर्किट. म्हणजे काय, ती त्या मोबाईल, आपला जो मोबाईल डिव्हाइस आहे त्याच्यात जी ऍप्लिकेशन्स पाहिजेत तेवढ्यासाठी ती चिप डिझाईन केलेली असते आणि ते तेवढंच काम करते. ती जनरल पर्पज चिप नाहीये. बरोबर आहे. मोबाईल मधली जी चिप असते दॅट इज द ASIC, ऍक्च्युअली ऍप्लिकेशन स्पेसिफिक इंटिग्रेटेड सर्किट. ती तेवढंच काम करते. टू रिसीव्ह द कॉल, to generate the call, right? And different applications to enable the what we can say internet, to connect the DHCP server, then IP packet transfer, IP packet receive. म्हणजे हे जे सगळं काही डेटा कम्युनिकेशन देन जनरल पर्पज यूज असतात, बरोबर आहे. ती मोबाईलची चिप फक्त त्या तेवढ्याच पर्पज साठी बनवलेली असते. उद्या ती चिप काढून तुम्ही अजून काय तर तिसरं मी प्रोग्राम करतो त्याच्यावर म्हणाल तर ते होणार नाही. व्हाय? बिकॉज ऍप्लिकेशन स्पेसिफिक, it is designed for a particular application, whereas if you consider the simple example of microcontroller, that is not ASIC. का? कारण ते मायक्रो कंट्रोलवर तुम्ही काही डिझाईन करू शकता, काही इम्प्लिमेंट करू शकता, बरोबर आहे. इफ बाय युझिंग मायक्रो कंट्रोलर you can blink the LED. By using that same microcontroller you can what we can say, you can operate LCD display, you can operate buzzer, you can operate stepper motor, you can operate different DC motors also with some motor driver IC. म्हणजे तो जनरल पर्पज आहे, म्हणजे बरोबर आहे, तो स्पेसिफिक नाहीये. असं आहे का की फक्त बाय युझिंग मायक्रो कंट्रोलर इफ यू कॅन ओनली एबल टू ब्लिंक द LED, तर देन दॅट विल बी द ASIC. ते जर का फक्त कुठल्या तरी एका पर्टिक्युलर डिझाईनला किंवा ऍप्लिकेशन साठी तयार केला असेल तर त्याला तुम्ही ASIC म्हणू शकता, राईट. सो युअर मोबाईल चिप can be considered as a ASIC, whereas the normal controllers, processors, they are not ASICs because they are meant for the general purpose use. They are not meant for the any specific use, right? So that is what ASIC is. So the same example is given there, right? The chip designed solely to run a cell phone is a ASIC. बरोबर आहे. आपली जी फोन मधली जी चिप असते that is actually the one of the best example of application specific integrated circuit, right? So as you know, the future size of the what we can say the technology and the chips are get shrunk, right? आपण नॅनो टेक्नॉलॉजी कडे चाललेलो आहे. त्यामुळे size of the actually their target board or ASICs are nowadays reducing considerably. Then the design tool improved over the years and the maximum what we can say complexity, right, as a functionality is possible in an ASIC. म्हणजे तुम्हाला जर का if you want to reduce the size of your chip, then you have to go for ASIC only. That means it should be a specific purpose. It should be a designed for a specific purpose. Then you can consider that, right? So the typically ASIC can have as much as 5,000 gates, and it can be extended up to over 100 millions of gates. म्हणजे एक सिंपल तुम्ही तुमच्या मोबाईलची ASIC घेतली, it has a more than what we can say 30-50 billions of gates. It is there, बरोबर आहे. तुम्ही ज्यातलं जर का प्रत्येक डिझाईन मध्ये जर का नंबर ऑफ गेट्स तुम्ही कॅल्क्युलेट करत गेलात तर त्या एका सिंपल तुमच्या मोबाईलच्या ASIC मध्ये you can find a millions of gates in present in that very small chip. Millions of gates are present in that very small chip, right? So that is the what we can say strong advantage of getting ASIC, right? Now the modern ASICs are include entire 32-bit processor, memory, then blocks, different ROM, RAM, EEPROM, flash, right? Everything is there in that simple ASIC. Everything is there, right? So and one of the again best advantage of this ASIC is by using a simple Verilog or VHDL, you can program that ASIC, right? By using a simple language that we are studying, using Verilog or VHDL, you can program that ASIC. That means designer have such a strong tool to program that ASIC as well as Verilog, right? So that is about the ASIC, application specific integrated circuit, right? Now we will differentiate between the PLDs versus ASIC. Okay. Now what are the merits of ASICs, that is application specific integrated circuit? So it is a long design cycle. Obviously, to design what we can say IC or a circuit for a specific application, it will take a time. That means it's a longer design cycle, but performance is faster. Why? Because after design, जे आपण ज्या ऍप्लिकेशन साठी ती बनवलेली आहे ते ऍप्लिकेशन किंवा ते ऑपरेशन ते फास्ट करणार आहे. जरी ते डिझाईन करायला वेळ लागत असला तरी एकदा डिझाईन केल्यानंतर त्याचं स्पीड काय असणार आहे, फास्ट असणार आहे. का? कारण ते फक्त त्या ऍप्लिकेशनचं काळजी घेणार, or it is meant for that particular application. So obviously the speed will be more. And the third merit is low cost if produced in high volume. Obviously, जर का if you have manufactured that ASIC in a bulk quantity, obviously the manufacturing cost required will be lowest or low. So this is about the ASIC. Now what is difference in PLDs, that is programmable logic devices or programmable chips? So it is a good for medium to low volume products. Okay, that means if you want to design any general purpose board or general purpose IC, then PLD, the programmable chips, are very good. And if you need more than 10,000 chips, then go for ASIC or hard copy. That means these PLDs are good for the lower volume products. That means if you want to produce or if you want to manufacture that quantity bulk, but still at with very limited quantity as compared to the ASIC, then you can go for the programmable logic chips. But if you want to go for like 10,000 chips, 20,000 chips, 50,000 chips, then you must go for the ASIC, that is the application specific integrated circuit. Or the product requirement is low, then you can go for these chips. And also one more difference that we have already discussed, this PLDs can be a general purpose. बरोबर आहे. Programmable chips can be a general purpose. For example, your microcontroller, it is a programmable chip, but it is a general purpose chip, right? You can implement any design by using microcontroller. But in case of ASIC, that is for example the mobile chip, you cannot have that facility, right? You cannot have that facility. So this is the difference between PLD versus ASIC. Okay, now we will discuss about the next types of the PLDs that are available, that we have discussed, that is CPLDs and FPGAs, that is complex programmable logic devices and field programmable gate array. Now this is the list, or these are the different manufacturers which produces the different FPGAs and CPLDs. So most popular and world recognized manufacturers are the Altera. Altera is a company name. That Altera is very leading company in the manufacturing of FPGA and CPLD, as well as Xilinx is also leading company. Xilinx is also manufactured what we can say, a range of CPLDs and range of FPGAs. And now we are what we can say, in different applications or space communication applications, we require these FPGAs and CPLDs only because of the fast speed, right? Because of the fast speed and fast execution, we require this CPLD and FPGA. So Altera and Xilinx, these are the two companies that are the leading manufacturers of this what we can say, CPLD and FPGA. Okay, so this part, that is we have to study this CPLD and FPGA architecture in detail, right, with some examples. So this part we will discuss in next lecture. Today we will stop here. Okay, whatever we have covered up till now, if you have any doubt or query, you can ask me right now. समजलंय का सगळं?
Yes. Yes, sir.
Okay, fine. Then we will stop here.